Hey folks, in this video, let's understand TikTok's recommendation system. Before we dive in, let me first give you the context on the workflow of a typical machine learning system. Let us say, initially we have a specific user-related dataset. We can train a machine learning model using this dataset. Note that the model training will consider certain hyperparameters based on the distribution of this dataset. Once the model is trained, it is put into production to serve users. Whenever a user sends the request, the model sends back the prediction based on the input data provided by the user's request. This new data collected from user behavior is appended to our original training dataset. Since the training data has changed, the model needs to be trained again on a regular interval of certain days depending on the use case. It is not practically possible to retrain this model every minute because the training data usually contains millions of examples. Whenever the user is watching certain types of videos, we want to recommend similar videos in the next few minutes. But with this system, we can recommend similar videos at least after a day when the model is retrained. So, how does TikTok solve this problem? Let us first get some basics cleared about TikTok's ML systems. TikTok uses a deep learning framework called TensorFlow to implement machine learning algorithms for their recommendation system. Internally, TensorFlow creates a computation graph for a machine learning algorithm. This execution graph contains nodes that represent arithmetic operations and edges that represent input data or model parameters. If you want to understand how TensorFlow works internally, I would highly suggest you to watch this video on our channel. Usually, TensorFlow stores this execution graph and the values of the model parameters in the same place. But TikTok's recommendation system decouples this into two separate components. The model component contains the execution graph, whereas the parameters component contains the value of the parameters. The parameter component stores weights and biases of the ML model and personalized user embeddings. These personalized user embeddings represent each user on the platform and are used to generate personalized recommendations for each user. Set of servers that store model component is called model server, and set of servers that store parameter component is called the parameter server. Let us now design TikTok's recommendation system using these two components. TikTok's recommendation model has two phases, the training phase and the serving phase. The training phase contains the training dataset, which is converted into sets of mini batches. These mini batches are passed to the model servers to train the machine learning recommendation algorithm. The parameters of these trained models are saved in the training parameter server. Once the model is trained, the model servers and the parameter servers are copied and put into serving mode. In this phase, the trained model will serve users. Whenever the user requests for video recommendations, the model generates a list of videos and sends them back to the user. But then, how to improve the model based on user actions? The model training phase and serving phase are disconnected, and that is why this model is not yet taking the user's preference into account. To solve this, the mobile application monitors for users' action. For example, a user likes certain videos, clicks on certain types of ads, and buys certain types of items after looking at ads. The user application pushes this user's action data to the Kafka message queue. If you want to know more about message queues and other system design components, then I would highly recommend you to watch this video on our channel. On the other side, the model server generates features from the user's behavior on a specific video. For example, how long the user has watched the video, the user's location, gender, etc. The model server generates these features and pushes them into a different Kafka message queue. For the recommendation machine learning model, user actions serve as input labels and the model-generated data serve as input features. Now, to create a training example, we need to join input features and input labels. To do that, TikTok has a component called Flink Job, which joins user action data and model-generated features. Why give such a fancy name to this component? Well, we will talk about it in a moment. As of now, the Flink job joins input features and input labels to create training examples that can be appended back to the training dataset. Now, the model can be trained on this newly added data immediately. This is called online training. The new parameters are stored in the training parameter server. The training parameter server can now be synchronized with the serving parameter server. The synchronization is usually very fast because all the parameters are not needed to be synchronized. Only the personalized embeddings for this user needs to be synchronized. Now let's come back to our discussion on the Flink job. Is it just joining the features and labels? No, it is doing much more than that. The joiner can only create training examples if both feature and label data are available. But sometimes, users' action data gets delayed, and because of that, joiner has to wait for it. While it waits, it has to store the feature data somewhere. It stores the feature data in a separate cache. But sometimes, the user's action data is delayed for days or even weeks. In such cases, the cache may not be enough. That is why it stores the cache-evicted data in persistent disk storage. Whenever the user's action data arrives, the joiner first checks in the cache for feature data. If it is available in cache, it is taken from the cache. Otherwise, it is taken from disk. Negative sampling is applied to this newly generated data because the incoming user behavior data is often imbalanced. This is how TikTok's recommendation system looks. The details discussed in this video are taken from ByteDance's recent research paper published in September 2022. I hope you find this video useful. Please like this video, subscribe to this channel, and comment down what you want to watch next. See you in the next one.